Linear inequalities, do you remember in Algebra 1, graphing lines and then deciding solid or dashed lines, shade up, shade down? Do you remember those graphs? They kind of looked something like this. And then you would shade one side of the graph. Okay. Solutions of inequalities. The shaded stuff is the solutions. So, points over on this side of the graph in the shaded region, those would be solutions. Points that are over here are not solutions. So, shaded region is all of the possible solutions for the inequality. To check whether or not an ordered pair is a solution, you're basically going to plug that point in and see if it makes a true statement. So, if the x and y values, if the point creates a true statement, then it's a solution. So simply remember that ordered pairs are a combination of an x and a y. If you substitute the x value in place of x in the inequality, substitute the y value in place of the y, see if it makes a true statement. So let's check 0, 1 with this inequality right here. So 2 times 0 plus 3 times 1, and we're checking to see if that is greater than or equal to 5. Is 3 greater than or equal to 5? No, that is a false statement. That means that the point 0, 1 is not a solution. If we try with the point 4, negative 1, 2 times 4 plus 3 times negative 1. Is 5 greater than or equal to 5? That is a true statement. So the ordered pair 4, negative 1 is a solution. Try C on your own. In your notes, this paragraph basically explains what I said in this picture. So the shaded stuff is the solutions. Any point in the shaded region is a solution. Any point not in the shaded region is not a solution. There's steps down here for graphing a linear inequality, but let's just dive right in and do it. Y is greater than or equal to 2. One thing that you should probably notice here, is there any x in this equation or in this inequality? No, so this is a HOI. HOI with y equals and no x is a horizontal line. So horizontal line at a y value of 2. Now if we have this symbol, this is the greater than or equal to symbol. Is this symbol going to tell us to draw a solid line or a dashed line? Solid line. A solid line is like a shaded line. The boundary line is part of the solution, so the boundary line is shaded. So we're going to draw in a solid horizontal line. In these step-by-step instructions, it says to decide which side of the boundary line to shade, you need to test a point. Pick a point on one side of the boundary line and test it. If it's a solution, shade that side. If it is not a solution, shade the other side. So we can do that, or greater than, bigger, shade up. So basically, greater than symbols, you shade up. greater than or equal to, either of those. Less than symbols, you shade down. So in this one, we are going to shade up. And this should kind of make sense. Y is greater than or equal to 2. So we need to shade on this coordinate plane all of the y values that are larger than or equal to 2. All right, now the next one. X is less than -1. Do you see a y in this equation? Inequality. So this is Vux. This is a vertical line at -1. Should we do a solid line or a dashed line? Dashed line. If the nose has a mustache, it's a solid line. If the nose doesn't have a mustache, it's a dashed line. I don't know if that's going to help you remember it or not. But if it's or equal to, you're shading in the line by making it solid. This is just less than, so we are not including the boundary line. The boundary line needs to be dashed. Okay, now the shade up, shade down trick is kind of difficult when you're working with a vertical line, because how do you shade up from a vertical line? So think about what less than means. We need to shade the x values that are less than -1. Shade the x values that are smaller than -1. Less than, left, shade left. If you are a highlighter or colored pencil aficionado, this is like your section of the notes. Although I think this highlighter just made the dashed line very difficult to see, didn't it? I'll make it easy to see. Just give me a sec. There we go. Okay, now, you don't have to put this in your notes, but I want to make sure that we take the time to do this. I'm going to put 3 points on each graph, and I want you to decide if these points are solutions or not. So, is A a solution? Yes. Is B a solution? Yes. Is C a solution? No. Is D a solution? Is E a solution? No. Is F a solution? No. So notice a point on a solid boundary line is a solution. A point on a dashed boundary line is not a solution. Now technically we have learned how to graph using standard form. So if we wanted to look at this and do 4x is greater than or equal to 8, find your x-intercept. 2y is greater than or equal to 8, find your y-intercept. We could. The problem with graphing standard form is that you absolutely have to test a point to figure out which side to shade on. You can't just do greater than means shade up. So I like to rearrange the equation to make it look more like y equals mx plus b. If we were going to rearrange this equation, how do we get this y by itself? Subtract 4x. So we have 2y is greater than or equal to -4x plus 8. Then divide everything by 2. We are going to graph y is greater than or equal to -2x plus 4. Okay, remember, in this equation, your y-intercept is 4. Your slope is -2. That means from your y-intercept down to right one, and so on, and so on. This is a greater than or equal to symbol. Are we going to use a solid line or a dashed line? Greater than or equal to. So our line is included in the solutions. Our line needs to be solid. And then are we going to shade up or down? Shade up. All right. So solid line. As your lines get closer and closer to vertical, up can be kind of hard to see. So here's a trick. Put your pencil anywhere on your line and draw an arrow straight up. Whatever side of the line that arrow is on, that's the side that you need to shade. So if you're ever struggling with which side to shade on, you can use that arrow trick. And when in doubt, if you really are having trouble figuring out which side to shade, test a point. You don't have to test a crazy point. You can test a super easy point. For example, I could test the point 0, 0. 0, 0 is a super easy point to plug in. Go to the original equation. 4 times 0 is 0. 2 times y, 2 times 0 is 0. Is 0 larger than 8? No. So 0, 0 is not a solution. Shade the other side of the line. So when in doubt, you can test a point. All right, let's get started on number 4. What do we need to do first? Subtract 3x. So we have negative y is less than negative 3x plus 3. How do we get rid of the negative in front of the y? And what happens to an inequality when you divide by a negative? You flip the sign. Okay, once we have this, so divide by a negative, that means we flip this sign. Take a moment, finish graphing that. Again, if you're struggling with shading up or down, check a point that's not on the boundary line. A point like 0, 0 is easy to check. 3 times 0 is 0. 0. Is 0 less than 3? Yes. So that point would be on the side that we shade. Write a linear inequality in 2 variables to represent the number of CDs, x, and the number of music videos, y. Could you say that CDs, that it's $10 per CD? Could you use that language? Anytime you can say per, that means multiply. So $10 times the number of CDs that you buy, plus $20 times the number of music videos that you buy. Leave a space for a symbol, and we have $200 that we can spend. The stuff that we buy over here, can that be bigger than 200? Can this stuff be less than 200? Yes, or equal to 200. What you need to remember here is that your x represents the number of CDs you can buy, and your y represents the number of music videos. So, discuss 3 possible solutions to this real-world situation. It doesn't matter where you pick your points from. Pick 3 points in the solution area. Like my first point is 2, 3. What does that point mean in this situation? It means I can buy 2 CDs and 3 music videos. The second point, the coordinates are 6, 7. So that means I can buy 6 CDs, 7 music videos. The coordinates of this one are 11, 3. I can buy 11 CDs and 3 music videos. So it's just asking you to look at the solutions and think about what do the solutions in the solution range actually represent, because that helps you to connect the equation, the model, the graph, and what it all means.